So this is far tougher than I'm going to ask you on your test, okay? In fact, on your test, I'm almost certainly, in the homework, there have been a few questions with ramps and things. I've been trying to let you know, Spencer, all the stuff that we've done this year, we can still fold into work and energy and make it, no pun intended, work just fine. But I think right now, mentally on your test, I'll give you roller coasters and such, but it's going to be flat level ground, not rampy things. Okay. Person pushes with 85 newtons on a lawnmower, pushes. I need to dulp. So they're pushing. I could draw the pushing like that. I tend to think about the lawnmower handle coming in that way at an angle. Did I say angle? So I'll come back to that because I haven't done this in the correct order. This is a job for a free body diagram. Here, and get the obvious one. Get the obvious one. No. We're doing a free body diagram. Get the obvious one. You know this. Everyone's staring at you. You're tired. Lena, help her out. I can't hear you. What? MG. What else? Now, Lena, normally, no pun intended, I would go to normal force, but is there an angled force here? Don't do normal force. That's going to be weird. Did I say angle? This is a job for components. Now, this component is going to look like this. Fy this time is going to point down. Fx is going to be this way, and our angle theta, 25 degrees. Now let's do the normal force. Is the normal force here going to be bigger, smaller, or the same size as mg? Yeah, bigger. I'll exaggerate. And I do that on purpose because I don't want to miss out later on. Hello, you, right? Do I need to have a force pointing to the right? I already do. Fx. Is there friction in this question? Okay. So this is going to be a little awkward. I'm going to do it kind of down there so it's not overlapping with Fx, and I'll make sure I don't forget. Okay. What does A want me to find? Okay. There's two ways we could do this. We could go we could say right? We could say looks like the distance we're traveling is 40 meters. And then if I wrote those three down and I said find VF, most of you would say, oh, you know what I really need to find? What do I really need to find? And so we would say A equals, and we could go winner minus loser. But I'm going to say to you, we could do it a different way. We could also, don't write this down, because I think this is the way you're more comfortable with, and we're going to do it that way. But we could go, so write that bit down, but we could go could do that, where the change in potential, I think it's 0 because we're on a flat surface. And I should be fussy. This is the net work done on an object. What's my initial kinetic energy? 0. So the change in kinetic energy is going to be a half m v squared. There's the v. Okay. What would the net work be? The total work being done is Fx times distance. The net work would be Fx times distance minus friction times distance. Do you notice no matter what in either approach, whether I go winner minus loser, where I'm going to go Fx minus friction, or work, where I'm going to go Fx times distance minus friction times distance, both times, somewhere along the way, we are, without realizing it, Matt, going Fx minus friction. Just one time it's being multiplied by the same distance. And then in our winner minus loser, we would divide by the mass to get the A by itself. I'm willing to bet if we walk through the energy approach, I'm willing to bet somewhere along the way, Lyndon, either the M's would cancel or I would divide by a mass. They really end up being identical, which is why they're on the same footing. Which one do you want to do? Do you want to do this with energies, or do you want to do this with accelerations and forces and winner minus loser? You want to try this with energies? Okay. So, this ends up becoming the network equals a half mv final squared. Let's find the network. The net work done is going to be the work done by Fx minus the work done by friction. You okay with that, Eric? Okay. Let's find the work done by Fx. The work done by Fx is going to be Fx times distance. Oh, Matt, work is what times what? I missed my cue. I apologize. You were feeling left out. I could see. Fx is a job for some trig. Adjacent hypotenuse. This is the one that I know. It's 85 newtons. Is it cos again? Of course it is. Okay, that's kind of convenient. So it ends up being 85 cos theta. What was the distance? 40? What about, I'll change colors, the work done by friction? Well, that's going to be the force of friction times distance. Friction is what times what? So it's going to be the force of work done by friction is going to be mu times the normal force. I don't know the normal force. It's not mg. It's mg plus Fy. FYI. Okay, so you're telling me this is going to be mu mg plus Fy times d? Fy. Is it fine? Well, that's convenient. So the work done by friction is going to be mu mg plus 85 sine theta times 40. Is that right? Let's crunch both of these here. So work net is going to be 85 cosine here, Fx, work done by Fx. Sorry, let me go back. Lyndon, I said the net work is the work done by the horizontal component minus the work done by friction. So the horizontal component is 85. What's theta? I've scrolled down. Was it 25? Cos 25 times 40 minus, what's mu? I don't know. What's mu with you? What's mu? 0.15. Mass? I'm sure I gave it to you, didn't I? No, there's a mass in there, folks. There's got to be kilograms in there. 20? Times 9.8. Mr. Dewick, yeah. Why do you always write the times sign? Honestly, because I have a bracket there and a bracket there, I'll do myself a favor and not put yet one more bracket there. I know it's going to confuse me. So you may have noticed almost always for that mg in the lawnmower question, I'll put a, just to keep it track of stuff. Too many brackets can also be ugly. Plus 85 sine, what did you say, 25? And then that is also times 40. There's a couple of ways you could do this, by the way. Lena, are both of these multiplied by 40? You could go 85 cos minus blah, 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 and then when you hit answer, multiply that whole thing by 40, because the 40 kind of factors out, or you can type it into... Let's try typing this in one fell swoop. I think we can. 85 cos 25. I have to close off a bracket times 40. Take away 0.15 bracket 20 times 9.8. Take away 85 sine 25. I have to close off the sine. I have to close... Oh, it's plus, not minus, Mr. Dewick. Thank you, Mitra. Candy for you. I was doing pulling up, which is one, I think, but we did more of that. But here we're pushing down. Times 40. Now let me double check, Mitra, because you threw me off my game here. There is there's the work done by Fx. And then we're losing energy to friction. If I just asked you for the work done by friction, you would have called it negative. Here I've got the negative with the minus sign. Mu times the normal force, which is mg plus, close, I think that's right. You get 1690? Yeah. That's the net work. And so now I can say 1690 equals a half mv final squared. I can go back to the very first line where I said, you know what? That's going to be my change in kinetic. Because there is no change in potential, and kinetic initial was 0. Is this faster than going winner minus loser, finding A, and then going VF squared? They're about the same if you count the number of lines. It's within a line of each other, and so really it's whatever you're more comfortable with. And I suspect most of you, because we did forces last year and this year, and I didn't get a chance to touch on energy last year, are probably more comfortable doing this with forces. But times by 2, divided by m. Told you we'd be dividing by m somewhere along the way. Square root. It's going to be 2. All right, 1690. I'm going to use my answer button. What was the mass? 20? Square root. No, not divided by answer button. Let's try that again. 2 times answer button divided by 20. Square root. Can you guess what I started with when I reverse engineered? Yeah, 13 meters per second. What's part B want me to find? There is a part B, isn't there? I think. What's part B want me to find?
Rate at which energy is generated.
The rate at which... What's that a synonym for? Power. At which energy is transformed into what?
Heat.
Oh, so this is going to be the power from heat, which is going to be the work done by heat over time. Did they give me a time in this question? No? Did they give me a distance in this question?
Yes.
Did they give me a VI in this question? Do I have a VF now?
Yes.
Could I find T? Probably. Okay. Now, you don't have an equation that has a VI, a VF, a D, and a T in it. You did in Physics 11. It was the D equals bracket VI plus VF over 2 times T, which you might remember, and if you did, great. But you know VI, you know VF, you know D. You could find A, and then you could go T is VF minus VI over A, which is why that equation is so redundant. It's an unnecessary one. So we could find T. What's the work done by heat? Why? That's the work done by heat. We could find this. But I'm not going to solve the rest of this. This is getting ugly. I want to get to today's lesson. Just to let you know, though, Eric, for what it's worth, we now have a lot of different approaches to solve the same kind of an idea. And let me emphasize, I'm not going to give you one this ugly. I'm not going to give you a lawnmower question on your test, because I gave you a lawnmower question on your last test. Mr. Dewick, when are we going over the forces test? We'll probably go over the forces test just before we do the energy test, because energy is because work is, Matt, what times what? So why don't we review forces as part of our leading up to that test? Graphing review. Graphing tricks. How to memorize less. Put your pencil down, look up. So I'll show you that video at the end. Ready? There are many different types of graphs, but I'm going to give you some tricks for some physics graphs. In particular, Spencer, for the remainder of the year, there's a good chance on tests or quizzes or in your homework, I may give you a graph and I may say to you, Ange, tell me something about the slope. What does the slope mean? Or tell me what the area under this graph means. And no one memorizes all the graphs. We get clever. If when y is 0, x is 0, if a graph goes through 0, 0, and as x gets bigger, y gets bigger, as x doubles, y doubles, as x triples, y triples, we say they are direct variations, or y varies directly as x. Direct variations, that doesn't look very clear. We write this: y is proportional to x. The symbol for is proportional is a little fish in math. In fact, and we would read that as y is directly proportional to x, because there's nothing around there. Now, if I want to turn that into an equation, I need to come up with some kind of conversion factor or some kind of constant of proportionality. If I want to turn it into an equation, we would write this: y equals, we use a lowercase k for the word constant because I think it comes from the German word, and I think the German word begins with a k for constant. You have seen that a bunch of times. Every single 3-variable equation we've done. F equals ma is a great example. Force is directly proportional to acceleration. If you actually want to solve, the constant that needs to go in front of the a turns out to be the mass in kilograms. Ta-da! There are lots of others like that. So K is called the constant of proportionality. I am not going to ask you these terms on a test, but I may use them in homework, or I may say they're directly relational, directly proportional, and I'm expecting you to remember, oh yeah, that means it goes through 0, 0. You know, it's a 3-variable equation, nothing else. The graph would look like that. Oh, not only that, by the way, since y equals mx plus b, but if b is 0, not only is k the constant of proportionality, it turns out it's also what you think of as slope. Okay? The slope of this graph is k. And so for the remainder of the year, I will feel comfortable giving you a graph that you've never seen and asking you something about it. So here's an example. Now this one we did last year. This is a distance versus time graph. What's the slope of this graph? You might have memorized last year, the slope of a distance or displacement versus time graph is velocity or speed. But I'm going to show you a better way to figure this out. Okay? Because you've memorized all that you already need. Because if I say to you, slope is what over what will all of you say? Slope is what over what? You've all memorized rise over run. Okay? If I get a brand new graph and I'm trying to figure out what the slope means, slope is what over what? Let's write that down. Rise is the y-axis. Kyle, what's on the y-axis? Look at the units. Per. What's on the x-axis? Has your teacher told you it's worth memorizing what units go with what? You know what? What do I measure in meters per second? So you never needed to actually memorize the graph. If you recognize the units, I got to be fussy. It's probably speed because it's a distance versus... It could be displacement. I don't know. Hey! This is speed. There's a second type of graph. It's very similar to the first one, except it doesn't go through 0, 0. we say there is an indirect variation if it doesn't go through 0, 0, but still when x gets bigger, y gets bigger. And we write this. Y is proportional to x plus b, or erase that if you want to turn it into an equation. And you can see it's actually slope-intercept form in disguise. When we're talking about proportionality, we put a k there, but really it's y equals mx plus b. You learned this in Math 10. So, here is a velocity or speed versus time graph. What's the slope? Lena, did you memorize that? How can you figure it out? Slope is what over what? So this is going to be meters per second per second. How many S's are there on the bottom? 2. What's a better way to write S? Hey! This is acceleration. What's the Y-intercept? What does it mean? In this graph, what does the Y-intercept tell me? What does it tell me? I know it's 3, Captain Obvious. What does it tell me?
That's your VI.
What?
That's your VI.
Ah, so are you saying if I go y equals mx plus b, this ends up being v equals at plus vi? You know what? There's where the equation vf equals vi plus at really comes from. Why we write the vi in front of the at, I don't know. It's just always the way I've seen it written, but it comes out of slope-intercept form. Okay, what would the area underneath this be? Ooh. Ready? No one memorizes this. I'm going to show you a trick that you can figure this out. So if it's the slope, you go rise divided by run. To find any area, what's the formula for the area of a rectangle? Did you say times? What's the formula for the area of a triangle? Base times? You will not find a single area formula that doesn't have times in it. So, if you're trying to figure out what the slope means, divide the units. Oh, and if you can't figure it out from the units, divide the variables. If you're trying to figure out what the area means, multiply. So this is going to be meters per second times second. What happens to the S's since I have one on top and one on the bottom? Oh, so I'm left with, boys and girls, what do I measure in meters? I gotta be fussy. I think it's the vector version. Yeah. And I didn't need to be taught that. I derived it. All I need to know is something I already know, that slope is rise over run divided by, and any area you multiply. Fair enough? What that means is, in real life, there's hundreds and hundreds of graphs out there, and as far as I'm concerned, I can now give you anything and ask you to either tell me the slope and what it means, 3, what it means, 3, what it means, or tell me the area and what it means. Put your pencils down, look up. There's a third possibility. We're going to run into this one in the next unit. And it's when if x gets bigger, y gets smaller. We say when x increases, if y decreases, we say that y varies. I hate that term. We should say it varies reciprocally. Because you learn in Math 12, what's an inverse really? It's when you switch the x and y around, which is not what's going on here. It's not your fault if you find inverse and reciprocal confusing. We screwed up the terminology in physics and in math. Usually it means your equation looks something like that. Or if you want to make it an equation that actually works, something like that, I'll give you an example. There. Or, even better, if you have a constant force, as your mass gets bigger, what happens to the acceleration if your force doesn't get bigger but things get heavier? Your acceleration's got to get smaller. So here is an example, and I don't know what. Do you have those squares on your sheet too or not?
Yeah.
Okay, I don't know what. I'll have to retype this. It's typed about 8 years ago and Word is acting up. Here is I in amps. This is current, resistance in ohms. This is an example of a graph that's related inversely. Hey! What would the area underneath this graph be? I don't know. Oh, what are they asking for? Area or slope? Let's try multiplying the units, because area means multiply. I get amps times ohms. I have no idea what that is. Instead of multiplying the units, let's try multiplying the variables. I get I times R. Who remembers from Science 9 what equals I times R? We called it Ohm's Law back in Science 9. If you had a good Science 9 teacher, he would have done this with you back in Science 9. I heard it. What? It's voltage. And that's the Mitra, that's the beauty of the two tricks I've just showed you. You derived and figured out a graph from the depths of your memory, even though you'd never seen the graph before. Area, multiply the units. If that doesn't work, multiply the variables. And 99% of the time, Ange, you'll recognize it. Slope, divide the units. If that doesn't work, divide the variables. 99% of the time, you'll recognize it. So you can make a little note here. Fourth possibility, which you already saw in Math 11, y can vary directly as x squared. We get the good old parabola. In fact, we're doing one right now. Kinetic energy equals a half m, what? If we graphed kinetic energy versus speed, we'd get a parabola. Oh, and it would go through 0, 0, because when your speed is 0, what's your kinetic energy? Okay? Sometimes you don't want to deal with the curve. If you go on to physics next year, you'll learn procedures for what we call curve straightening, because we're really good at analyzing lines, but analyzing curves is a pain. If you wanted to straighten this out, instead of graphing kinetic energy versus V, you would graph kinetic energy versus V squared. What's the slope of this graph? If they're asking about slope, what's the trick that I do? Times or divide? Let's try dividing the units. It would be joules per meters squared over... I don't recognize that at all. Let's try dividing the variables. It would be KE over V. Hey, is there an equation that has KE and V squared in it? Yeah, look at that equation on your formula sheet, and now rearrange it so that you have KE over V squared. What's left behind on the other side? The slope of this would be half of the mass. That was a question from a provincial several years ago. They gave the kids this graph with numbers, and all the question asked is, what's the mass of this object? And people freaked. People freaked. First of all, if it's a graph, I'm telling you, it's either going to be the area or the slope. Try both if you're not sure. Try the units first. That doesn't work. Try the variables. And I've taught you well enough. Trust me, folks, you'll get it. So this is how we're going to do graphs for the remainder of the year. I will, because I showed you a graph for this unit. What's the another way for work was the area under a force versus distance graph. Area multiply. Oh, that is force times distance. And there's going to be a force versus distance graph on your test, I guarantee it. And you're going to see for the remainder of the year, most units will have a couple of new graphs as well. You can memorize them, but you don't need to. So, on some tests in your future, you'll be asked to interpret a graph. To figure out what quantity is represented by the slope, simply divide the units or the variables to figure out what quantity is represented by the area, simply clever graphing tricks. Do you do graphs in chemistry as well? Who's in Chem 12 here? Yeah? There. This is how you can memorize all the different... no one memorize... You can memorize all the chem graphs. I just showed you how you can figure it out with a bit of cleverness. Is it the slope that they want? Is it the area that they want? I don't know.